again, this is from Chapter 2, Review Exercises number 29. I tried to get the graph as accurately as I could, and it's not very good necessarily, but it's close enough, and I think it's good enough for us to talk about the solution here. The question said to arrange the following numbers that I listed up here in increasing order from least to greatest then. So from least to greatest, we need to try to establish something about the quantities at this point. Now, this is the graph of f, and we need to see what these values are doing on this graph. So f prime of 2. Well, f prime of 2. 2 is right here, and on my graph, it sort of looks like what it does in the book. My graph's a little steeper than in the book, but the tangent line here at 2 is positive. Okay, so if I was to draw a tangent line right here, it would be going up from left to right. So that tells me that f prime of 2 is greater than 0. F prime of 2 is positive. Now, is it greater than 1? We're gonna have to look a little closer in the book to figure that out, because on my graph it kind of looks like it is, but in the book, not quite. F prime of 3, and I'm just glancing at the book to see how well I did. Similar analysis, we go over here to where 3 is, and we were to think about drawing the tangent line right here. Okay, and now I'm drawing a little arrow here. I should probably just delete that. I don't like that arrow. We can see from there that f prime of 3 is also greater than 0. And if you look in the book, f prime of 3 is greater than f prime of 2 because the slope is steeper at 3 than it is at 2. So I can start putting this type of thing in there. We already know f prime of 2 is greater than 0, so I'm not going to write that in there. F prime of 5, now again, glancing over in the book, 1, 2, 3, 4, 5, it's almost horizontal, okay? And so it's really slight right here like this. And so this is almost 0, and even in the book, this is going to be smaller than these two values here, okay? So I'm not going to write it yet, but f prime of 5 is less than f prime of 2 even. So it's less than f prime of 3. Now f double prime of 5, if I look at 5, I have to judge the second derivative by the concavity of the graph of f. And now since f is concave downward when x equals 5, f double prime of 5 will be negative. Okay, so I'm going to just note that here. F double prime of 5 is less than 0 because f is CC down. At x equals 5. Alright, so we have a rough sketch here. We know what goes first. So f double prime of 5 is negative, so that goes first. That's the only negative value, so then after that would come 0. And now we have to determine the positive values. The only thing we really don't know at the moment is where 1 fits into these positive values. We know f double prime of 5, f prime of 5 is the smallest of all the positive values other than 1 at the moment, because it's the most horizontal. And I think you'd all agree if you look in the book that f prime of 5 is darn near close to 0, and so it's going to be smaller than 1. So I'm going to stick in f prime of 5 right here. Now, again, looking at the book, and if I was to sketch a graph, or sketch a tangent line to the graph of f at x equals 2, it looks to me that f prime of 2 is also smaller than 1. So if you want to argue with me about that, that's fine. Bring it up to me in class one day. We'll bring out a ruler and try to measure and see. But it looks like f prime of 2 is smaller than 1. It also looks like f prime of 3 is bigger than 1. So it looks like 1 would go right here, and then f prime of 3 would go last. So once again, we're looking at the graph of f, and by looking at the graph of f at these specific values, we're able to determine the relationship, roughly, of the derivatives at certain points, a couple of constants, 0 and 1, and the second derivative at one point. And hopefully that was helpful.